Hi guys, welcome to another Learning Electronics Repair video. I have two identical motherboards here. These were sent to me by a subscriber, the vintage motherboards, retro gaming motherboards if you like. Pentium 4, socket 478. This one has a CPU fitted, the fan is missing from the north bridge. This doesn't have a CPU, but I have plenty of CPUs for these. This has the fan on the north bridge. This one, he says, is his board, the one he would like to see repaired. This one apparently stops on some BIOS postcode that is meaningless. And this one is a good working board sent for reference. He's swapped the BIOS and it makes no difference to the error code, he tells me. And he says he's changed this chip, although I haven't looked to see what the chip is, and he sent me some of these as well, but apparently it made no difference. And then he asked me if I could see if I could repair this one. So, given the fact we have two boards, we might have a reasonable chance of at least figuring out what the problem is with this and hopefully repairing it. I'll power them up and then let's have a look to see what we actually have here. I have the good working one connected up. I've put some sort of old NVIDIA AGP card in here, and I've noticed something interesting already. So if we put the post analyzer in this slot and we switch it on, start it up, you'll see the analyzer goes to 25 and it just stops, doesn't do anything. Yeah, it just doesn't boot with the card in at all. So if we take the post analyzer out and we retry that, and there is also a display on the board here as well. We'll take the post analyzer out. We'll start it. And it bleeps. And we get a picture from the BIOS. Yeah, you see it there. So, in fact, it is working. I tried quite a number of different graphics cards. Some of them will actually give like 1 long and 3 short bleeps when the post analyzer is in here and stop on 26. And in the end, I ended up testing some of the AGP cards on a known good motherboard of mine. Found a couple that are definitely working, tried again, still had the same problem. And then I discovered that the problem is actually the post analyzer, which is very unusual, I will say. So if we switch that off, what I have noticed is if we put the post analyzer here, yeah, switch it back on again. And now it works. So it just doesn't like the post analyzer in that end slot, you can see it there. So we do have a good working board. This goes to 7F. Although on here it's saying 1A, this is saying 7F. It's saying CPU. Oops, got it close to the file. It's actually saying CPU is unworkable or has changed. Please recheck. So it's asking me to change something in the BIOS, but at least it is booting. And that's all I'm really concerned about at the moment. So we'll switch that off. We'll put the same CPU in the other board. We'll connect this the same. And now let's see what it actually does. This then is the non-working board. I've used the same CPU and RAM out of the other one for now. This one doesn't have the fan on here, but I will actually try taking it from the other one and just making sure that it isn't something stupid like won't power up if the fan isn't fitted. In the meantime, just get the CPU fan. Okay, I'll just power it without that, but I'll just keep an eye on it just to see, or should I say keep a finger on it, just to see if it's getting overly hot. Now I noticed straight away this is doing something different. So when I switch this on, this display here, let me just discharge the capacitors. Okay, the other one goes to 01, 3, and this one goes to F. So it gives a different code when you first switch on before we try to start it. That may be relevant. Now let's power it up. And in fact this one will not start. There's no CMOS battery on this one, so that's something we should try. Okay, I have the battery, the power's off at the moment. So we'll put a good CMOS battery in. There we go. Now let's have a look. So 3F, so it's doing something different. Yeah, and this one doesn't want to start, so it's not behaving. Oh, there we go. The owner said it was giving a meaningless code. Maybe he means that. I actually have to ask him if that's what he was getting. If that's the case, whatever the problem is, it appears to be before we even try to start the board. So at the moment, the only thing that's actually powered up on here is standby. So there's only really going to be the SIO chip, possibly the north and south bridge will have some power. I think I'll try first to see if I can actually find a schematic for this board. Okay, so I think we know a few things about this, or at least one thing about this. I've now removed the CPU, I've removed the RAM, and I'm just switching the board on. And we can see this goes to 3, then F dot. Okay, so that's with just the board with nothing plugged in. So I'm pretty sure what's going wrong with the other one is happening before we get to the point of trying to power most of it up. So it's happening when we just have 5V standby supply and nothing else. Okay, so let's again try the other board with nothing attached to it and see what it does. And I am expecting this one to go to 0, 1. So that's in there. You couldn't see it, but that's in there. Yes, that's it. Again, nothing plugged into the board. We don't even need the bleeper because it's not even getting that far. We just need power. Let's see what it does. So we power it up. 3, 0, 1. So we know now definitely whatever the problem is, it's something before the main supply 5V, 3.3V, 12V come on. What I think I'll do is now I'm going to switch it on and leave it for a few minutes, then get a thermal camera and see if I can see anything getting warm, and then try the same on the non-working one. Right, I've left it on for a few minutes. Let's see if we can see anything in standby. Well, something back here. This one just a little bit warm. That looks like the audio chip. Well, it could be something to do with the LAN actually. It could be a LAN. I mean, you'd expect the LAN chip to be on because this thing has power on, you know, starting by LAN, yeah? This one obviously has got a little bit of warmth as well. This is probably the SIO chip. I'd have to check the port number. Let me see, make sure you can see this. Yeah. So a little bit of warmth in that one. Bit in that one which makes sense because it'll have power on from LAN. All this should be off really because it's not powered up. Again, this should all be off. I'll just move it so you can see it. Nothing really down there. No. That's the display itself. LED display, a little bit of warmth. Nothing in this south bridge here. A little bit of warmth in this chip, so this obviously has power to start. Where's the thing you changed? This thing. No, that's cold, so that can't be involved. And I guess there's going to be a couple of MOSFETs somewhere on here that are actually probably stepping down to 3 volts. Looks like this chip might have a little bit of power in it. But that's what we have. That's on the good board, yeah. You can basically see what may be powered up. And it's kind of what you would expect, really, yeah. There's this one here as well. That's reflective, so that might not be warm. Okay, so that's what we have. So let's if I measure the temperature. So About 30.3 on that one. 31.9 on that one. A little bit of power on this thing by the looks of it. 30.1. Okay, let's try the other board and see if we see any obvious differences. That's been on for a few minutes. Whilst I let it warm up a bit, this chip, which is one of the ones getting slightly warmer than the other one, that is the LAN controller. So this will have standby power because this has startup on LAN. This one is the FireWire controller, which I'm guessing it must have some sort of startup on FireWire, or 1394 as it's called, IEEE. This is the SIO, which is involved with the startup sequence. So that's what those chips are. The other thing this would have on standby would be power to the USB, because it almost certainly have Wake on USB. I'm going to have to check, but I wouldn't be surprised. And it'll have Wake on keyboard, but that'll be controlled by this, I would expect. So let's have a look to see if we can see any difference on the thermal camera. Okay. Well, the main difference is, from what I can see, this is cold. This is much hotter. This one. I can actually feel a slight warmth. No, it's not much hotter. It's glowing brighter on here. I'm not sure if it's particularly hotter. Yeah, it's maybe slightly warmer. This one is about the same as the other one. And the FireWire is about the same as the other one. So the main difference appears that the SIO is not warming up at all, like it has no power. Is there a power rail missing? Maybe. This possibly is glowing a little bit more than the other one, but it's a bit subjective. But I'm interested to see what's happening with this, because it looks like it has no power on our board. Here is the datasheet for the SIO chip. This is the one that's cold on our board and a little bit warm on the other board in standby. It's not exactly the same. Ours is the HF/AW. This is HF/F. So there may be slight differences, but it'll be basically the same. What I'm interested in is the power connections coming into this. You see, this chip is responsible for the parallel port, serial port, keyboard interface, and a number of other things. Yeah, power pins on page 19 we're interested in. It will also be responsible for the power to the button, the on button on the ATX motherboard. That should have power, and it will get the signal coming back when it grounds that to tell it to start. So we can also check to see if we have power to our on-off switch. That would be useful. Just scrolling through the contents, and then we'll come to what we're looking for. It's quite a long document. This is a pinout for the version F and HF, which ours is the HF. Various pins and signals, but I think at the moment we're just interested in the power, so we can have a look through and see what we have. I think this is a parallel port, this is a serial port, keyboard, ACPI, hardware monitor. Oh, that's the difference with the H version, it has hardware monitor, which ours has, but I don't believe it's even getting this far. We have, keep going, game port, power pins. Okay, so it has a 5-volt supply. This is the main 5-volt supply. It has a 5-volt standby, which we should have on pin 61, so go make a note of that. It'll probably have the 3.3 on 28 as well. We can check for that one. And this is ground. I'm not too worried about the other two at the moment. We can come back to them if we need to. So pin 61, pin 28, and imagine there's nothing on these when it's in standby, but we can have a quick look on both the good and the bad board. I'll make a note of those pins, and then let's have a look on ours. So this is the bad board. The voltages I've marked and I actually found one more. So pin 74 is VBAT, that's the CMOS battery, and then VSB standby is on 61, so the pin goes from 1 to 38, then we go up to 64, 65, we can go round. So from this we basically know where the pins are. So first of all, without it powered up, I should be able to find VBAT. So VBAT is on pin 74. This is pin 64, 65, so I can count down these to 74. 65, 6, 7, 8, 9, 0, 1, 2, 3, 4. So here we should have the bat. I may have just miscounted. 5, 6, 7, 8, 9, 0. This one. And we have 3 volts on there. So we have VBAT. Now let me connect the standby power without trying to start it up and see what we've got on the other pins. Okay, I now have it powered up. So let's have a look again. The VBAT should still be there. So let's have a look again. So that is on this side on pin 74. Starting from 65. So 65, 6, 7, 8, 9, 0, 1, 2, 3, 4. And in fact the voltage gone up a little bit, which tells me that we have actually got a 3.3 volt supply somewhere on this board. You'd expect that to go up when the power is actually there. We have pin 61, which is standby 5 volts. 64, 3, 2, 61, and that is 5 volts, that's good. And then the last one is the 3 volt supply, which is on pin 28. So this starts from 38 counting downwards. Let's have a look. So 8, 7, 6, 5, 4, 3, 2, 1, 0, 29, 28, which is this one. And that only has 0.237 of a volt on it. Let's have a look at the good one in comparison with that. Again, we should check them all while we're here. So let's have a quick look. So pin 74 was VBAT, starting from 65. 65, 6, 7, 8, 9, 0, 1, 2, 3, 4. Yep, that's there. And then it was a fourth one in, 64, 3, 2, 1, 5 volts. And this is the one I think will be 3.3 on here. I think it was that one. The one next to it. Okay, let's count it. 38, 7, 6, 5, 4, 3, 2, 1, 0, 29, 28. It is this one. And actually no, that reads the same. So that voltage must only be there when the board is powered up. That's a shame, because I thought I might have been onto something there, but apparently I am not. Another thing I did mention we should check is the power supply to the on-off switch, the power on switch. So let's have a look. So this has 0.535 and this has 5 volts. So that's a 5 volt supply. It looks like this board doesn't have a 3.3 volt standby. It just has a 3.3 volt supply which goes to this when it powers up. It looks like the 5 volt is the only standby apart from the battery voltage. Let's have a quick look on the bad one. Okay, here's the bad board again with the code F on here. Let's have a look. So this was about 0.5, it's the same. It looks like we probably got 5 volts to there. So we do have a 5 volt standby. So far then, the only difference I can really find is this chip is cold on the bad board. Then, I mean, I don't have any schematics for this. I can say that from what I've seen, both the chips have power. It runs off 5 volt standby and it runs off VBAT, and they both have that. If that's the case, I'm suspecting maybe I should swap this chip or swap it between the two, because I can't think of any other reason why this would be running cold if it has a supply and the other one runs a little bit warm. It tells me the other one's doing something, this one isn't. Yeah, there's one other thing I would like to try, and that is the real-time clock, the crystal, to see if it is oscillating. I may be able to do this with the test meter, I may not, But first of all, let's just give that another look to see whether it has any warmth in it. Okay, so we can see on our board that chip is cold, yeah? Let's power it off and power it on while we are looking with the camera. And I want to try this again on the other board as well. So we'll switch it off. We'll switch it back on and let's see if anything happens with it. Well, apparently not. Yeah, apparently not. There's a bit of heat in that one, as we said. Let's see what this one's reading. 31.3, so it says. And this one has a little bit of heat in it as well. But not much, yeah. That's the warmer of them. Okay. Let's try the good one again. So here's the good board again. I'll switch it on looking through the thermal camera and let's see what happens. Yeah, that's warmed up straight away, yeah. And this has less warmth in it, but I haven't given it the time to actually do something. But we can see straight away that SIO is doing something on this board. And this probably looks about the same. Yeah, it looks about the same sort of temperature. We're not sure if you can see it because of the glare off the overhead cameras. We can have a look. So that's that one. Now you can see the difference. Absolutely see the difference on the SIO. So that must be telling us something about this. And to me, it's telling me that the SIO on the other board is dead. There is another thing I'd like to test on this as well, and that's to see if the real-time clock is running, because basically if the real-time clock isn't running, this will never start up. So the crystal is here. It's quite probably connected to this chip actually, and we can have a look. So I'm on the oscilloscope there. I'm not sure how well you can see it, but yeah, you can probably, I'm sure you can see it. So this is the crystal. So on this one it is running. This is the good board, the one with the 01 code. Let's have a look on the bad one. Here is the bad board once again. Now let's have it, see if this one's running. Yeah, you can see it there, it's the same, it's running. That just wants the trigger setting a little bit. There you go, yeah, got it. So the real-time clock's running. It's just that this one just doesn't warm up, and without any other information, it's hard to say. I think what I would do is see if I can replace this. I could take the one off the other board and swap them over, but these are customers' boards and one is working, so he may not want me to do that. Let me have a look to see if I can actually get one of these, or if I even have one of these. Yes, we can buy these from AliExpress. They're cheap, less than €6 for two SU8MS. I trust this seller. So one possibility is to just buy a couple of these and see if it works. So we can see that it's fairly inexpensive to get these. There's another thing I'd just like to check, but I don't think it's going to give us much more information. Then I'll try and put it all together, explaining what I think and why. So what I would like to just measure is the drain from the CMOS battery. That goes into this chip, so the real-time clock is in here. This controls things like the USB, the SATA, IDE and so on, yeah. So just positive to the battery, I'm on the microamps range, and push the little clip back. Now reading 7.14 microamps. I just want to compare that with the other. I have this plugged in but the power supply is off, by the way. I've unplugged it now anyway. So again, well, actually it changed slightly even though the power supply is off. Yeah, it's not even powered up. And we now have 7.8 microamps. Let's look at the other board. I'm thinking this one might be drawing slightly more because the VBAT goes to that chip as well as here. But let's have a look and see if we get anything conclusive. So what we got, so onto the battery. Yeah, this one's drawing slightly more. That ties in with the fact you'd expect that is drawing like a microamp or so. That I think kind of settles a lot for me. There are a number of factors coming here together. You've seen the evidence, you've seen the same as I've seen what's happening. So on the bad board this is cold, on the other one it's warm. And when I say warm, we're probably talking not even a degree or maybe a degree or so. I didn't check the difference, but it's very little difference, even though that thermal camera is very sensitive, and we'll show you that difference. That's great. So this one isn't powering up. The draw from the CMOS battery is a little bit lower, a microamp or so, kind of makes sense because it goes to there. I did wonder if this chipset has a 3.3 or 1.8 volt standby voltage, which is generated from the 5 volts. So 5 volts standby in before you start it. On more modern chipsets will generate a 3.3, maybe a 1.8 or both. And that then goes to these chips as well. And it's a low power thing, so this is the typical thing where we have a PCH, which is basically these two chips combined on a modern chipset, gets hot and standby. We know it's dead. Yeah, it's burning up to get hot. They shouldn't in standby because those standby should be low current. But if this chipset had a 3.3 volt standby from here or a 1.8 volt standby from here, it would have somewhere on the board a little linear voltage regulator or MOSFET that's dropping the 5 volts down. And although it's drawing low power, that would get warm enough to light up on the thermal camera like this is. Yeah, and we can't see anything. We can't see anything. I also had a quick look at the data sheet for this, and although it does have a 3.3 and a 1.8 volt supply, it doesn't appear to have them in standby, which is a very long data sheet. I could be wrong there. Another factor is this chip is responsible for communication with the serial ports, parallel port, keyboard, and the various things you can stick in the back of here to a fair extent. That means it's effectively exposed to the outside world. It's therefore possible, for instance, we might have serial port connectors on the motherboard. I haven't really looked. If you plug something on wrong, it's possible you would damage that. So that's another factor. And the last factor is these are known to fail. Yeah. So yes, I'm sure there could be some component around here that's stopping this from working. Something stupid, it could be, yeah. But the fact it's got power, the real-time clock's running, and the current measurement from here really makes me think I've got a dead SIO. Confident enough to try it. There's another factor, this is time. How much time would it take to diagnose it further rather than just order these? But this is now a repair community, guys, yeah? So, in the famous or infamous comments below, this is not meant as a part 1 and part 2 interactive repair, but what do you guys think? Do you think Richie is onto the right track here, or do you think I'll order some of these after the weekend, after you guys have had your say, and maybe find it still doesn't work? Well, I'll leave you with that thought. You know where to get commenting, and I'll see you all soon on another Learn Electronics Repair video. Ciao for now, guys.